So we're now introducing the pH scale. What is the pH scale? It's used to indicate if a compound is acidic or if a compound is basic. And it has to do with, and the middle point is 7. It goes from 0 to 14. Then in between is 7. Anything lower than 7 is acidic. Higher than 7 is basic. And in 7, we'll have a pH that is neutral. So here we see some examples. Seawater is basic. Milk is acidic. So based on the pH. Again, when the pH is 7, we're in the presence of neutral solutions. When the pH is lower than 7, we have acids, and when the pH is higher than 7, we have bases. How do we measure the pH? Well, we use what is called a pH meter, and it's a device that looks like this, and we can determine the pH, or we can use pH paper like this. This pH paper, based on the color, we can determine the pH, or we can use universal indicator that changes color depending on the pH of the solution. So let's say something like this. The pH is 1.5, so it's an acid. When the pH is 1, when the concentration of H3O plus is -8, so we go back to slide number 28, and we see that if the concentration is greater than 1 times 10 to the -7, this is going to be a base. This pH is acidic, this one is neutral, and when in something like this is going to be basic. And again, you can look in slide 28 and you will see that anything that has a concentration of H3O plus smaller than 1 times 10 to the -7, it is a basic solution. So let's calculate, let's learn how to calculate the pH. The pH is going to be calculated using this formula. pH equals to the negative log of the concentration of H3O plus. So let's do this problem. The concentration of H3O plus is given, so we say pH equals negative log of the concentration of H3O plus. So pH equals to the negative log of this value, and the pH is 2.77. All right, let's do the same. They are giving us again the concentration of H3O plus. What will be the pH? The pH will be the negative log of that number. Put it in your calculator and you find that the pH is equal to 5. Now they are giving us the same concentration of H3O plus. Is this? What will be the pH? So the pH will be again the negative log of that value, and that gives us 3.7. The last two problems are different variations of it. Now, instead of giving us the concentration of H3O plus, they are giving us the concentration of OH minus. So for that, this is a little bit more tedious. We need to remember what we were doing. Kw equals concentration of H3O plus times the concentration of OH minus, correct? So we're going to solve for this one. It will be Kw over concentration of OH minus. And concentration of H3O plus is equal to 1 times 10 to the -14 over 1 times 10 to the -3. And we find the concentration of H3O plus to be equal to 1 times 10 to the -11. Then we find pH is equal to the negative log of that, and when we do the math, we find that the pH is equal to 11, so the answer was option B. All right, the last problem is to calculate the pH, the concentration of H3O plus if I give you the pH. So this one works like this, negative log of this value. So we need to solve for this. The inverse of the log is in the calculator. You see is the key that says 10 to, that's the inverse of log. So what you guys are going to do is the following. The concentration of H3O plus is equal to 10 raised to the power of the negative pH. So you, in your calculator, you just write this 10 to the negative 8.25, and that will be the answer. Concentration of H3O plus equals to 5.6 times 10 to the negative 9 molar.